2C, multiplication of whole numbers. Multiplication is just the repetition of addition, or you can say it's just adding over and over again. The result of a multiplication problem is a product, and the numbers being multiplied are the factors. Now, I bring up the factors when I did not do that with addition and subtraction. I didn't bring up the addends, and I didn't bring up the subtrahend and the subtractor and all these things, because I don't feel that they're really that necessary in addition and subtraction. But when you're dealing with multiplication, the factors, the numbers that are being multiplied together, and the product, the result of that multiplication, it's important that we recognize those terms, because a very common thing that we do in mathematics is factoring, which is basically finding the numbers that multiply to a certain product or some other number. So it's important for us to understand what the term factor means. Factors are numbers that are being multiplied together to form a product. So let's look at what multiplication really is. 3 times 6. So if I have 3 times 6, multiplication really is just saying that's 6 plus 6 plus 6. That's all it's saying. 3 times 6. We're going to take 6 plus 6 plus 6. 6 plus 6 is 12. Plus 6 is 18. That's what multiplication is. It's just saying, take the second number and add this many of them together. 2 times 7 is equal to 7 plus 7. It's 2 times 7. We're taking 7 2 times and adding together. We're 3 times 6. We're taking 6 3 times and adding them together. 7 plus 7 is 14. So that's the basics of multiplication. It's just repeated adding. But you don't want to have to be always doing this repeated adding. So I'm going to bring it up again. You've seen it before. You're going to see it again. You should be able to do multiplication of single-digit numbers. So those times tables from way back when, and I'm going to bring up factmonster.com/math/flashcards. So factmonster.com/math/flashcards, or any other site that allows you to practice your multiplication tables. But get in there and practice them. Get where you can do your multiplication of single-digit numbers in your head. Keep practicing, keep practicing, keep practicing, get so you can do it. Because everything we do is going to be based on knowing how to multiply a single-digit number by another single-digit number. As we get into larger numbers, who cares about the larger numbers? It's all about doing single-digit times single-digit. If you can't do a multiplication with 2 single-digit numbers, then you're going to struggle on everything else. So please go through that. It's the practice and the repetition that gets it into your mind. So learn your single-digit multiplication tables. So now that we have that, and if we've practiced that, we can get into multiplication with multiple digits. But before I do that, I just want to throw out one more piece of information. What happens if you multiply by 0? I'm going to get rid of this marker because it's not agreeing with me right now. So what happens if we multiply by 0? Well, let's take a look at that. 0 times 7 equals. Remember, this number tells us how many of these we're going to add together. 0 times 7, we're going to add 0 sevens, which means I'm not writing any sevens here. So what's the result? 0. Well, what if I go 7 times 0? Well, then I'm going to write 7 zeros. 0 times 0 times, sorry, plus, right? Plus 0, plus 0, plus 0, plus 0, plus, what, 1, 2, 3, 4, 5, 0 plus 0. Well, 0 plus 0 is 0, 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 right? So, if we multiply any number times 0, the result is going to be 0. So that's something that we need to keep in mind. It makes things nice and easy. I can give you a horrendous multiplication problem, and it becomes very simple when I multiply it by 0. 7, 4, 9, 6, 3, 9, 8, 5, 8, 2 times 0 equals 0. It doesn't matter that this is a number in the billions. We multiply it by 0 and we get 0. Any number multiplied by 0 is 0. Which does make things quite easy for us at times. So just keep that in mind. Anytime you're multiplying by 0, the result is 0. So let's work on multiplying some multi-digit numbers. Well, what if I have 27 times, well, I'm going to start with 6. So a 2-digit number multiplied by a 1-digit number. So what do? Well, we start here, and what we're going to do is we're going to multiply our way out. So 6 times 7, and if we know our multiplication tables, we know that 6 times 7 is 42. So we're going to put the 2 down here, and just like we did in addition when we carried, we're going to move that other digit up here. So we had 42, so we're going to put 4 up here. Now, we're not going to add the 4 to the 2. We're going to do the other multiplication. 6 times 2 is 12. Now we're going to add the 4. 12 plus 4 is 16, so we get 162. So we multiplied the first one, brought down the ones place, brought the other number up here, then we multiplied the second one and added this on to the result of the second multiplication. Let's do another one. Let's say we have 346 times 8. So 6 times 8 is 48. Bring a 4 up here. 4 times 8 is 32, plus 4 is 36. Bring a 3 up here. 8 times 3 is 24, plus 3 is 27. So our multiplication, if we're multiplying any number of digits times a single digit, we just work our way through. Multiply, bring down the right-hand digit, put the other one up here. Multiply, add that to it. Bring the other one up here. Multiply, add this to it, and bring it down. So that's dealing with multiplying by a single digit number. So let's extend this out a little bit more and see what do we do if we're multiplying a multi-digit number, something that's more than one digit, by another number that's more than one digit. So let's say I have 83 times 26. Well, I start out the same. 6 times 3 is 18. Bring up that 1. 6 times 8 is 48, plus 1 is 49. Okay, so we multiplied by this first digit. So took this first digit and multiplied by all the numbers at the top and worked our way across, as if we were doing single digit multiplication. Now here's where things change a little bit. I now want to do the same thing with this 2, but notice this 2 doesn't really represent a 2, it represents 20. This is 26, not 26, 26. So it's worth 10 times as much. That's 2 tens. 20 is 2 tens. 10 plus 10 is 20. So I'm not going to start here, because if I multiply through it, I do 2 times this and put it here, it's going to be treating it as a 2. So what I'm going to do is I'm going to put a placeholder 0 here, because notice this 2 is in this column, so that is where I'm going to start my result. So I'm putting a 0 to line everything up with that column. So now I go and I'm going to get this out of the way, because if I don't, I may make the mistake of reusing that carry, and we don't want to do that. 2 times 3 is 6. 2 times 8 is 16. So now I've multiplied these through, and basically what I've done is I've done this. I've done 83 times 6, and I've done 83 times 20. Well, if I do 83 6 times, and I do 83 20 times, then if I add those two together, that's the same as doing 83 26 times, isn't it? If you're working out and you're doing reps, if you lift, just to keep my numbers easy, if you lift 100 pounds 10 times, and then you lift 100 pounds 20 times, didn't you lift 100 pounds 30 times? 10 times the first bout, 20 times the second bout, a total of 30 times. So if I take 83 6 times, and then I take 83 20 times, I've taken 83 a total of 26 times, so I am going to add the result of 6 times 83 to the result of 20 times 83. So I'm just going to add it. 8 plus 0 is 8. 9 plus 6 is 15. Carry the 1. 1 plus 4 is 5. Plus 6 is 11. Carry the 1. 1 plus 1 is 2. So 83 times 26 is 2,158. That's multiplying multiple digits. Let's do another one. And I'm going to do one that's a little bit bigger, just to show that the method expands depending on the number of digits in your numbers or your factors. So let's say I have 3,482 times 695. Now, when multiplying numbers, line up the rightmost digits. Now, as we get to decimals, I'll show that it doesn't have to line up the place values, you line up the rightmost digit. So when you're dealing with whole numbers, that rightmost digit is the ones place, so that always lines up. When we switch over to decimals in a couple more sections, you'll see the effect that that has on decimals. So now I'm going to do the same process. 5 times 2 is 10. Carry the 1. 5 times 8 is 40. Plus 1 is 41. Carry the 4. 5 times 4 is 20. Plus 4 is 24. Carry the 2. 5 times 3 is 15. Plus 2 is 17. I'm going to get rid of those carries so I don't reuse them. I'm now moving over to the 9 in the tens place, so I'm going to put a 0 here as a placeholder. In fact, to make it clear that that's a placeholder, I'm going to put that in a different color. So we've got a 0 there as a placeholder. So now 9 times 2 is 18. Carry the 1. 9 times 8 is 72. 72 plus 1 is 73. Carry the 7. 9 times 4 is 36. 36 plus 7, 43. Carry the 4. 9 times 3 is 27. 27 plus 4, 31. And again, I'm going to get rid of these carries so they don't get in the way for the next one. So now I'm going to multiply by 6. Well, that's in the third column, so I'm going to put zeros in the first and second column, so I don't start there. So now it's, instead of multiplying by 6, it's the equivalent of multiplying by 600. 6 times 2 is 12. Carry the 1. 6 times 8, 48, plus 1 is 49. Carry the 4. 6 times 4, 24, plus 4, 28. Carry the 2. 6 times 3, 18, plus 2 is 20. And now the same as we did last time, now that we've got those, we can add them. So zeros give me 0. 1 plus 8 gives me 9. 4 plus 3 is 7, plus 2 is 9. 7 plus 3 is 10, plus 9 is 19, carry the 1. 1 plus 1 is 2, plus 1 is 3, plus 8 is 11, carry the 1. 1 plus 3 is 4, 2, put my commas in place, and I have 2,419,990. So it's the same process, and it doesn't matter how many digits I have you multiply, you're going to follow the same process. Take the first digit, the rightmost digit of the bottom one, and multiply it through the whole number on the top. Get rid of those carries, come to the next number and put a 0 placeholder so that you line up with the number you're multiplying with. Multiply that all the way through. Get rid of those numbers, come over to the next one. We want to line it up with that place, so we're going to fill in zeros to make that line up, and we're going to start multiplying through again on that one. And we keep doing that, building this little triangle of zeros that are bumping it over one place each time, and then we add it all up, and that gets our final result. So 3,482 times 695 is 2,419,990. Now there's a couple more things I want to point out to you, but these processes, that's multiplication, and notice that we were really just doing multiplication of single digit numbers the whole time. So if you know those math facts and you can say 6 times 7 is 42, 9 times 8 is 72, 5 times 2 is 10. If you can do these quickly and on the top of your head, then you can do multiplication of whatever size numbers. So 2 other things I want to talk about. One is how you can write multiplication. 4 times 3 is the same as, so I'm just going to say is equal to, 4 times 3. Sometimes we use a dot between them. Now notice this dot is in the middle of the height, not at the bottom. It's not a decimal point. It's above, and that says 4 times 3. We can also say 4 times 3. If you have a number or something inside a parenthesis that's next to something outside the parentheses, that says multiplication. So these are 3 equivalent expressions for multiplying 4 times 3. I just wanted to make sure you're aware of those. And I'm even going to throw another one in here just because it throws people off when people use it. Now, chances are you're not going to see it done like this unless there's more stuff going on in those square brackets. But square brackets are really treated the same as parentheses. So this is still 4 times 3. But sometimes you have to do multiple things and you want to separate some with parentheses and then use the brackets so it shows that all of this is grouped together. But we'll get more into that when we start dealing with order of operations. So that's the one thing I wanted to share with you. The other thing is a little side method of how to multiply multi-digit numbers. And personally, I wouldn't use this for doing the multiplications that we're doing here, But when you start getting into dealing with algebra, and I know people don't like that term algebra because that means we start dealing with letters instead of just numbers, this can become a method that allows us to multiply polynomials. Big word just means a number of items that are dealing with letters. So let's look at this and say, well, what if we have 326 times 45. And this is called the box method. So what I'm going to do is I'm just going to create a box, and I'm going to make this 3, 2, 6, or we can make it 326, right? And 45, right? 326, 45. So now with this method, you just fill in the boxes. 40 times 300. Well, what happens if you have all these zeros there? Well, amazingly enough, when you're multiplying numbers that end in 0, you can count the number of zeros and just add them onto the end. So if we have 40 times 300, 4 times 3 is 12, and then there are 1, 2, 3 zeros. So that's 12,000. If you have 40 times 20, 4 times 2 is 8, and then 1, 2 zeros, 800. 40 times 6, 4 times 6 is 24, and 1 0, 240. 5 times 30, 5 times 3 is 5 times 300, 5 times 3 is 15, 0, 0. 5 times 20, 5 times 2 is 10, 0 making it 100, 5 times 6 is 30. And now that we have all of those, we can add these up. So we have 12,000 plus 800 plus 240 plus 1,500 plus 100 plus 30. So I can add those up. So all zeros in the ones column, 0. 0, 4 plus 3 is 7. 8 plus 2 is 10, plus 5 is 15, plus 1 is 16. Carry the 1. 1 plus 2 is 3, plus 1 is 4. And then a 1 here, which gives us 14,670. So it's another viable method for doing the multiplication. I personally do not suggest using it. I share it with you as a possibility. If you feel comfortable doing this and you can get the answer correct doing this better than you can the other, you can do it. To me, it's more time and space consuming, and I really see it as just being extra work. But it's up to you to make that decision. So that's multiplication of whole numbers.